The following is a presentation of the Six Arrows Radio Network.
This week on the Workbench, designing a safety shutoff for Jeremy's soldering station. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy KF7IJZ.
The Workbench is sponsored by CADsoft, makers of Eagle PCB design tools. Get your free copy at cadsoft.io. And by MCM Electronics, where I can and you can buy all of your electronic parts needs and equipment. Check out mcmelectronics.com today.
Hello and welcome to episode 9 of the Ham Radio 360 Workbench podcast. I'm your host, Jeremy KF7IJZ. And normally we would also be joined by George, KJ6VU, but unfortunately he is on assignment this evening in a far-off land and will not be joining us. So this week on the Workbench, we have a little bit of a departure from our normal content. We're going to be walking through a live design session of a gadget that I'm calling an idiot switch, which we'll talk a little bit more here about in a moment. In the meantime, because this episode does run a little bit long, I'm going to kind of skip the news and I don't really have much to cover this week, but I do want to focus a minute on what I've been doing on my Workbench. So for the last few days, I've been playing around with digital radio hotspots, and specifically one in particular, which is the DV Mega. Now, myself, George, and Kale all picked up DV Megas at Dayton this year. We bought them directly from Guus van Doorn, who is the designer and manufacturer of these, PE1 PLM. And basically what this board is it's a board that has a dual band radio, a 2-meter 440 10 milliwatt radio. And you plug it into a Raspberry Pi, and it will turn your Pi into a digital mode hotspot. And the reason I say digital mode hotspot instead of a D-Star hotspot is Goose's board will actually support D-Star, DMR, and there's experimental support right now for Yaesu System Fusion. And so I've had this thing since Dayton, and it has been sitting in its bag, and I haven't really had an excuse to play with it, primarily because all of my Pis are busy crunching for Einstein at home. And I didn't want to go out and buy another one for this. And I've had a lot of other projects and have been busy and haven't really had time. Now, one of the things that Goose had at the booth at Dayton was a little device called a BlueStack Micro. And I didn't really understand what this thing was. But basically, it's a daughter card that if you don't want to plug your DV Mega into a Raspberry Pi to run a hotspot using software like MMDVM or Jonathan's IRCDDB or any of the traditional D-Star type hotspot software. This was a little board that would allow you to take one of Goose's Raspberry Pi radios, plug it into this board, the BlueStack, and the BlueStack offers two features. Number one is it provides a serial to Bluetooth bridge, so you can connect it to a computer or you can connect it to a mobile device, an Android mobile device. And it also has a built-in USB port, which can be used to connect it to a Linux computer or a Windows computer, and you can still use it as a serial device for traditional hotspot operations and again, use with software like MMDVM or IRCDDB. But kind of the cool thing is that in addition to using those traditional packages, there's a ham who has written some Android and some Windows software that makes it dead simple to be able to connect your digital radio to the internet connected portions of DMR or D-Star or even System Fusion, even though I think that support's coming in more maturity, both from the hardware perspective and the software. That ham's name is David, and his call sign is PA7LIM, and his application is called BlueDV. And again, there's an Android version, which you can find in the Play Store, as well as a Windows version that you can download from his website, which is pa7lim.nl. And what's cool about this software is that if you buy one of these BlueStack Micro Plus boards, which I found available from a company here in the United States called Grapevine Amateur Radio. Grapevine is run by the gentleman who runs the Ham Radio 2.0 YouTube channel. And I'd come across his video and saw that he was stocking these things. So for $45 plus shipping, I was able to order this from Texas. It comes via priority mail. It was at my house I ordered it on Sunday. It was at my house by Wednesday. And the cool thing is it took me longer to modify the code plug for my MD380 DMR radio than it did to get this thing set up and have me connected to the Brandmeister DMR network. Additionally, so the first night I played with it just on DMR, and so basically I have this 10 milliwatt radio that's running, and I have my MD380, which I turned down to its lowest power setting, and I ended up having like a nearly 2-hour-long QSO with a ham on the Ohio talk group. But it was awesome because I was sitting in my living room, I had the hotspot in my office, and the connection was flawless and perfect, and that was using the Windows software. The next night, I decided to experiment getting on D-Star, and out of the box, his software is compatible with the traditional reflectors, also the X reflectors and the DCS reflectors, which is something that in the older IRC DDB, you didn't necessarily get right out of the box. You had to do more configuration. But this application is really simple to use. And then I ended up having an hour-long QSO with a ham that I used to know when I lived in the DC area, W3ICF. Phil, who is responsible for building out some of the D-Star infrastructure in the kind of extended national capital region. And that was awesome. The communications quality was flawless, no drop packets. I was on my ICOM ID51A. I had it on its lowest power setting, and I was sitting in my living room talking to this hotspot connected to the computer. And then today, as an experiment, I took this thing along with me. I installed the Android software on my Nexus 7 tablet, and just had a USB battery that I had both the tablet and the BlueStack/DV Mega combination plugged into. And I ultimately was able to have a conversation with our friend Ed W4EDF. He was connected to the Alexandria W4HFH D-Star 2-meter module. I was on my hotspot, and it worked flawlessly. It was very simple to set up. I didn't have to necessarily know very much. And for somebody who is looking to get into a hotspot without spending a ton of money, this is maybe one of the best options out there, because you're out about $45 for the BlueStack Micro Plus board. The DV Mega is available in two options. There's a single band 440 option, which is available for about $130. And then there's the the dual band version, which we all wound up with, which will do 2-meter and 440, which is available for about, I think, $170, $180. And in the United States, you can pick both of those up at either Ham Radio Outlet or Gigaparts. But I have to say the package is really awesome. Now, granted, they're just raw circuit boards. You don't have a case. But, there are ones you can purchase either from Grapevine Radio or some other places online. Truthfully, I'm probably going to try to design one and print one myself because I have the capability to do that. And if I do end up finding the time to do that, I will make the STL file available probably on Thingiverse. But I will say it's been really nice to play digital radio. One device, two different modes. I didn't talk on Yaesu System Fusion, but when I got it up and running, I connected to, and I don't even know what they call them. I don't know if they're reflectors or talk groups or bridges. I don't know what the Yaesu terminology is because I'm just not familiar with Yaesu System Fusion. But I connected to one of the Wires X rooms or whatever in Alabama and was even getting traffic to my one and only Yaesu System Fusion radio. And so that's pretty awesome that you get all three modes. And again, it's dead simple to use. And if you want to use one of those more powerful packages like MMDVM or, IRC DDB or some of the other things that are out there, you can still use this either over Bluetooth or via USB. So really a fun little package to have on the bench, and something I'm very happy to have found a US distributor for the BlueStack board. So as I mentioned, tonight's episode is a little bit different from most. So if you haven't been listening for a while, you may not know that I was an idiot and left my soldering iron on for 2.5 weeks. Not 2.5 days, not 2.5 hours, but 2.5 weeks. I have a Hakko FX-888, which does not have a function in it to automatically turn itself off after any period of time. And I was just careless. I wasn't paying attention. The last time I had used it was to repair the charging cradle for my MD380, which was a very quick 2-second soldering job. and completely forgot about it. Thankfully, nothing was around it that could combust or catch fire, but the end of the pencil got pretty toasty, and at that point I decided it was probably best to just replace the soldering iron. So I started looking at other Hakko models of soldering iron, and they did have a model that does have an automatic shut-off, that there's a little micro switch in the iron cradle, and if you haven't removed the iron from the cradle in 30 minutes, it will automatically shut it off if you've configured it to. But that was like a $300 option. I knew I probably wanted to replace my iron, although I actually have been able to clean up the old tip a little bit by chucking it in my drill press and then working it with steel wool, and getting it back to some of the sheen back down, getting back to a completely uncorroded bit of the tinning of the tip. So maybe it's salvageable, but either way, I still wanted a way to be able to have the soldering iron turn itself off after a certain amount of time. And I got to talking about this actually on an episode and realized this might actually make a really interesting episode to record the conversation around describing the problem, looking at what are the points of interaction within the current Hakko soldering iron, what opportunities were there, and then actually working through a design and deciding what features it would have with a group of people. And so tonight we have, as usual, George, KJ6VU, but we've also brought back Beric from the Antenna Analyzer project, K6BEZ, and then we also invited our friend Nick, N3WG of Pignology, to come along, because all of those guys actually have some form of legitimate background in electronics. I have none. I am the lay person in this group by far. I have enough familiarity with the Adafruit catalog and companies like MCM and Electronics, etc., but I'm still not an expert. To do this, I'm going to be cobbling together components, whereas these guys could probably build, raw circuit boards and component everything out in analog electronics. What's particularly interesting about this, though, and what we wanted to share, was really showing you how design thinking works, especially in a group. Because the way that I approach this, I had a solution in mind of how I thought I wanted to solve this problem, and I did not share my solution with anybody because I didn't want to taint their viewpoints. All I did was give them some preliminary information and some access to some high-res pictures of the internals of this thing. And then, I basically wanted them to come have a completely fresh view on solving the problem. So in this episode, you will actually hear us talk about the problem. You'll hear us describe what some of the desired functionality is. You'll hear us start debating about how to solve it. And I will tell you ahead of time, the solution we came up with is not anything like what I originally had in mind. So we really hope that you enjoy this walk through the design process, and hopefully there's a lot to be learned here, again, about design thinking, or even how to approach problems, or how the first solution is not always necessarily the right solution. And if you are inspired to try building something like we talk about in this design, which we don't have any schematics or anything, but there's enough of a reference design discussed that you could cobble something together. Should you want to do that, please check in with our friends at MCM Electronics at mcmelectronics.com. They carry a wide assortment of project boards, Arduino, Raspberry Pi, components, and all the tools and other equipment that you need to outfit your workbench. Ham Radio 360 Workbench listeners can save 5% on their full order by using the code RADIO5 at checkout, and that applies to most things. Unfortunately, things like Raspberry Pi, they can't give a discount on, but it does apply to most things. So don't forget to check them out. We hope you enjoy the show. We'll be back after a few words about our sponsors.
The Workbench is sponsored by our friends at CADsoft. They're the makers of the Eagle PCB design software, the very software George used to design the Pactena Classic, Pactena Mini, what him and Beric are using to create this new antenna analyzer project for you here on the Workbench. They got hundreds of parts libraries, tons of reference designs, and a monster huge user community. Eagle's a great choice for your next ham radio project, and you can get your free copy of their software today. Click on over to cadsoft.io and start getting your project put together today.
This evening on the Workbench, we are joined by two special guests. First of all, we have brought back Beric Dunn, K6BEZ. Hello, Beric.
Hello.
And we are also joined by one of our earliest guests on formerly the Photime podcast, now Ham Radio 360, Nick Garner of Pignology, N3WG. Nick, how have you been?
I've been doing okay. I got a baby on the way, so I'm I'm taking it easy.
Well, it's a good thing we're getting this in now, because when the next little one gets here, you're not going to have any time, are you?
It's all over.
It was good knowing you, and we appreciate you giving us what little of your free time you have left. So, gentlemen, tonight we are here to solve my idiocy. So,
which one is that?
Well,
sorry, you opened yourself up for that one, Jerry.
You're right. I teed
Starting
it
a
up.
podcast.
Yeah. So, for those of you who have not heard in the previous 6 episodes that I mentioned it in, I had come downstairs one evening and was crawling around on the floor going through a parts bin, and I looked up and noticed that there was a blinking red LED on my desk. And then I stood up, and to my horror, I found that the blinking red LED belonged to my Hakko FX-888 soldering iron, which I had not used for 2.5 weeks. So everything on the end of the pencil was a nice, crispy black color, and I was mortified because I could have burned the house down, which is a no-no. And considering we want to practice safety and good practices here on the workbench, I thought this was there was a good lesson in here somewhere. Originally, I thought the solution to this problem was spending $300 on a Hakko soldering iron that turned itself off automatically. And then I said, no, I think we could design something. And that's really the crux of why we're here tonight. So I have gathered the minds, plus George, to get together to discuss designing a solution to create what I call an idiot switch. And that is a switch that is designed to not burn your house down with a soldering iron due to poor attentiveness. So before we jump into solving this problem, there's a very specific reason that we invited Beric and Nick back with us tonight. And again, it's because of their deep expertise in electronics. So Beric, I'll start with you since you've been on the show. Give us a little bit of your background on why you're qualified to keep my house from burning down.
I'm an electronic design engineer, and I've been designing circuits for the last 20 years, so I know a thing or two.
Were any of them involved in personal protective equipment or safety things?
No, but I have left my soldering iron turned on over the weekend before, so I have shared your pain when I picked it up on a Sunday.
Okay. And Nick, give us a little bit about your background.
Yeah, sure. Thanks. By trade, I'm a computer network engineer type person out here in Silicon Valley. And around 2009, I started writing some software for iOS and Android. And then in 2011, I got into making hardware, just with a hobby business. You mentioned it earlier, Pignology, and made a few products there. And then that sort of, once George and I got together right around the same time, that sort of morphed into making more hardware together, learning from George. He's an amazing mentor, despite what Jeremy says. And now it's pretty much hardware at least twice a week. I'm in some sort of circuit board. So I've got quite a bit of experience end to end, not just laying out the boards and making them work, but putting the code on them, making web services that talk to these pieces of hardware and things like that. So when George sent me the email asking if I'd be interested in doing this, it was immediately, oh man, I got an idea for that. And I'm sure we'll get into that. I'd rather just, start engineering right now, though, rather than, all this talk.
Awesome. All right. So let's jump into it. So the problem statement is, and of course, my background is in agile software engineering, so this might sound familiar to some of our listeners. But as a maker, I want my soldering iron to turn itself off so that I don't cause catastrophic damage to my iron, my bench, or my house. Fairly simple, straightforward, seed to begin with. Some of the acceptance criteria for this solution is that the soldering iron turns itself off after a configurable time period. The user is able to configure the timer through software or through manipulation of components, and the solution does not become so unwieldy as to threaten becoming tangled in the cabling of the iron or any other interaction that impedes safe operation of the iron. Now, are there any other acceptance criteria that you guys think we should consider, or any of this that you guys would want to challenge?
Well, I'll throw out one there, Jeremy. And I don't know if this is implied in your spec or not, but I would want something that's smarter than just a timer. I would want something that realizes that I'm using the iron and only shuts it off after a period of inactivity.
So I would argue that my spec still allows for that, because I'm just saying that there is definitely still a timer component involved, and haven't gotten it. To me, that part of it is more the how, not so much the what.
No, what I'm saying is that if you turn it on, and let's say you have a 1 hour timer, if you're using it and an hour goes by, you don't want it to just shut off. So it has to be smart enough not to shut off just because the thing timed out.
Agreed. So, and actually under my nice to have features, I have a way to reset the timer during use. And definitely would like to avoid having to crawl under the bench to manipulate anything in relation to this.
And can be so frustrating to use that you go and buy a new iron after making it.
Exactly. It would also be nice if the solution did not cost $200, because at that point you can just go buy a new iron.
Okay, so how do you want to do this?
So I have taken made the effort to have a decent understanding of how the iron is put together and some of the components, etc. But at the end of the day, I don't know how much research you guys had done on the electrical characteristics or how this thing is assembled or how it operates. So I would start off by ask some questions.
Are you wanting to actually take this iron apart and modify it in some way, or are you wanting something to plug the power supply from the iron into so you can use it for other things?
So I am looking for something that is an elegant solution that is integrated with the iron. So either one of those conditions could be true. Again, to me, that more gets into the how of what we're doing than so much the what. Because I think there are valid solutions that you actually are busting into the iron itself and mounting things to it or inside of it. And there are also solutions potentially where you're just plugging something into the end of the cord that could have more uses than just this soldering iron. That is actually something else that would be nice. We're designing this for the Hakko FX-888 or 888D, whose circuits are pretty much identical with some small changes, but it would be bonus if this solution could be used for other things that you need to shut off after a while.
So the criteria is essentially, if it's running too long, shut it off. For me, I would certainly prefer not to carve into the device. If there's a way to do it all external to the iron, I'd prefer that. That way I don't open it up and mess it up and potentially use it on another iron or another appliance or device.
Hey, I got one. Currently, so I have a Hakko as well. Big fan. Yours has the switch on the side, just a rocker switch. Is that right?
Yes, it does.
So is it acceptable for that switch to remain in the on position at all times?
So in my opinion, yes, that could very well be part of it. Those are the things that, again, to me, I don't, other than what I just laid out, I'm looking for, trying to come up with the best solution. That may mean that to necessitate the best solution, that you are going to leave the power switch on the body of the thing on all the time. But getting into that level of detail, like that's not something I'm going to set as a requirement, because I think that by doing that, when we put limitations like that on this, that automatically makes certain assumptions about things you're going to do either inside or outside of the iron.
Okay, so walk us through what some of the key features are inside the device.
Okay, so obviously it is a 120 volt, 60 hertz device. The switch itself is actually wired between mains and the transformer inside, so it is not an electrically switched device. In other words, like that power switch on the side of it actually has all the current from the wall running through it. The transformer, if I remember correctly, outputs 26 volts DC. And that 26 volts ultimately goes to, heating the iron up and whatnot. It is a 70-watt iron. The board itself appears to be a 5-volt logic level, and I'm only guessing that because I think there is a JTAG header or something, like a 4-pin programming or diagnostic header that comes off of the main microcontroller inside. And for my research online, somebody had said there was a 5-volt line there. Now, I had not found what was on the board that was actually going from 26 volts down to that. But, I included some very high-res photos of those boards that we can take a look at, because that's also something I'm just not smart enough to look at a board and say, oh, that's clearly doing XYZ. Additionally, the plug for the iron itself has 5 or 6 conductors plus ground. 2 of those are obviously for running heat to the soldering iron, and then there's a signaling loop for the temperature sensor in the tip of the iron that runs back into the board.
Yeah, looking at pictures of the board, there's multiple ICs and a bunch of surface mount parts. So cutting into things would be a little tricky unless you just connect to the big pass element that's in there or some of the wires.
Did you find a schematic?
I have not been able to find a schematic of the iron, no.
At the risk of jumping to a solution, I'm looking at the pinout for the iron. And the sensor there could definitely be used to see if the iron was being used rather than just sitting steady for a while. I mean, if the temperature changes suddenly, then it's being used to solder. But we could file that under useful information for later.
I wonder what the detectable change is, if it's a thermistor in the heat by the heating element, or what do you think it is?
It's probably a thermistor in the heating element. You could always, get your Regal scope out and take a look while it's running.
I could if I had some kind of like a pass-through box where I could actually get at the lines.
Well, often with these connectors, you could take the boot off and while it's still plugged in, probe the pins.
Yeah, it looks like 2 of the pins from the connector go to the board. They're labeled H1, H2, which I assume is like heating element 1 and 2 leads. And then the other white wire goes to some solder pads. And the wire obscures what the silk screen says in the circuit board, but it says SE something something. So maybe it's sense or sensor. So if that's the case, then the white wires go into a bunch of resistors around a 8-pin IC. So my wild guess is it's probably the heat sensor, and that's a little amplifier for the signal. That's probably then fed into an ADC in the microcontroller to read the temperature. That's a sort of big guess at this point.
And on the iron pinout, it's actually saying test sensor pin 1 and 2, 42 to 58 ohms. So, yeah, I'm not sure if that helps.
And I believe I've seen a picture of, it may be inside the unit itself, but I think there actually is like a resistor soldered between a couple of the pins.
All right. So what would you suggest? What approach would you take to this then? Maybe let's start with Beric.
Well, you could go minimal, something that just turns the iron off after a while, or you could turn it into a super duper or singing or dancing thing, which actually texts you to say your iron's been on for a while.
That one.
Actually, so this is good. Let's categorize these. So solution 1 is going to be completely dumb, purely timer based. In other words, you turn the iron on, and after a preset amount of time, I'm shutting the iron off. There's no intelligence gathering. There's no logic. It's literally 30 minutes have passed. Iron is going off. You must reset me.
So let me throw something out while we're starting to categorize these things. So in all the categories, one of the first things that I think about is how would I actually control the iron's on or offness? And since the device is plugged into AC and there's a mechanical switch to close the circuit, how would you interrupt and control that? And one thing that I found that's really, really handy is a little device. It's a plastic box about 2 by 2 by 3 inches that's got a relay in it and a little AC pigtail on either side. It looks like the world's shortest extension cord. So it's got an AC socket on one pigtail and an AC plug on the other pigtail with this box in the middle. And the box has got not only the AC relay, but it's also got an opto isolator in it. And you can run logic level 5 volts over to the opto isolator to engage the relay. And that way you don't have to actually mess with hardwiring any AC and being afraid that you're going to kill yourself because you didn't handle the wiring properly. So this would be a completely external packaged device that just goes in series with the AC power cord for the soldering iron. And all you need to get to it, to turn it on and off, is just put a 5-volt DC line on the opto isolator. So that way you could hook that up to a mechanical timer or a microcontroller or whatnot. But anyway, at least that gives you a mechanism to turn the thing on and off without worrying about AC wiring.
Well, and also the one point there is if you're actually just hard cutting off the power to the iron assembly, then whatever control circuit you have, Arduino, Raspberry Pi, whatever, that's going to lose its power at the same time as you cut the power to the iron.
Actually,
well, no, I assume you would power that circuit through a separate AC outlet.
Yeah, but it's just
unless you want a dead man switch. Once you shut it off, it's off
just
forever.
It's just something to consider.
Yeah. So George, kind of along that line, because I had looked at those, because Adafruit sells one that I think is like $25 or $30. That is exactly what you're talking about. It's a microcontroller 5-volt controllable 120 volt socket. And of course, $25 for that is an awful lot of cash when you look at some component level things. And of course, when I was looking at this, I was kind of looking at the relay approach also, and basically wiring it up to that switch. Of course, the risk there is you are dealing with bare wires through very tiny terminal blocks, that is household level voltage. But on the other hand, for the microcontroller, which I'm assuming we can use something like an Atmel like 328 or 32U4 or something like that. And I'm just picking this because they're small and they stack. So Adafruit now makes this microcontroller that's Arduino compliant called the Feather. Have you guys seen these?
No.
I don't know. Yeah. They're really small, like 3/4 of an inch wide by, I don't know, maybe 2.5 inches long. And the one I'm talking about in particular that has the 32U4 on it is nice because it has USB built in that you can actually use it as a device. But then they have these things called feather wings, which are like, hats or shields, but for feathers. And they actually make an Omron AC relay that would stack right on top of it, one circuit, and it'll do 120 volts up to 10 amps. And it's exactly what you're talking about. It's a 5-volt controllable relay.
And I think when you look at that, I haven't seen that, but I'm imagining what you're describing. Then the question is, how are you going to package it? Because you don't want raw AC sitting there exposed. So part of the complexity then becomes, okay, do I get a box that's big enough to put this whole thing in? So I don't accidentally touch the AC, which is, when you look at the cost, for instance, you might say, well, it's $25 for this external plastic box relay thing. And I can go get an AC relay for $10 or something like that shield. I don't know how much that is, but it's probably not less than 20 anyway. But now but for the Feather and that shield together, I think you're at $20 or $25, and that gets you the microcontroller. Mm-hmm. And it's quite a tiny package that stacks together. So to me, the reason it was attractive is because, number one, commercial product that's well supported, and they are physically and electrically integrated to one another. Because even if you bought the $25 pigtail, we still have not introduced any logic into the system. Yeah, well, for the logic, we could support that with, a $5 Arduino board. So I'm not saying that one is better than the other, but they're probably similar in price, I would imagine. So at this point, we're still, just to kind of catalog some of the challenges, right, is number one, how do I power this thing? It's number two, physically, where is it going to go? Number three, we're still looking at what are options for sensing, the status of the soldering iron. So all good stuff. Nick, you have been suspiciously quiet.
Yeah, I'm solving problems over here.
He's laying out a circuit board already.
I'm going to say,
yeah. He's waiting until we talk about the Bluetooth stack.
Yeah, I was I wouldn't Bluetooth the thing. I'd Wi-Fi it.
That way,
that Bluetooth's going nowhere.
Yeah, that way, like at night when I'm adjusting my thermostat, I can also go check to make sure my soldering iron is off.
Oh man, works with Nest. Good idea.
Actually, Jeremy, I do another question for you. You do have another soldering iron because you can't be using your current soldering iron inside the one you're actually trying to fix.
That's kind of a good point that I had not considered. So, yes, I will need access to... I will pull out my ancient Radio Shack 45-watt pencil that isn't at all up at 45 watts. The Hakko is what actually made me realize I'd been soldering incorrectly my entire life because I had picked up bad habits because of really substandard equipment. So, I wasn't used to having
the right
an iron.
thing really makes a difference, doesn't it?
Yeah, I didn't realize that it wasn't common to have to leave the tip on your circuit for like 20 minutes before solder would flow.
Hey, by the way, I'm looking at the Adafruit website, and that power switch tail thing I was talking about is the same one they have on their website, and they have another one that's called the Controllable 4-Outlet Power Relay Module, 1995, and it looks like the same idea, except it's got 4 outlets.
Instead of just one?
Instead of just one.
How
and
much is the single outlet?
Sorry? It's like $25 for the single outlet and $20 for the 4 outlet.
That makes no sense.
Well, they're made by different people. And funny thing is, the 4 outlet one is made by a company called Digital Loggers, and Digital Loggers is off the Central Expressway, which is the road that I take to go to work. I drive by these guys every day. They're here in the valley. So it's described as a single input signal to switch 4 outlets, 2 normally on plus 2 normally off. Universal control voltage, 3 to 60 volts DC, et cetera, et cetera. So this is pretty cool. This would be really cool if they put enough room in the case to actually let you put the microcontroller inside. That'd be even better. But it's got a little terminal strip with 2 screw posts, and you just apply a DC voltage to it to actuate the relay.
All right, so for those playing along at home on the recording and in the show notes later, I'm posting a link to that.
So it seems like at this point we're circling around a external AC relay to turn the power on and off. Any other ideas for enabling or disabling this?
Yeah.
Putting a relay on the heater wires on the front panel is another relatively simple way, which still allows the iron hardware to keep running.
Does that buy you anything?
It's a bit less risky voltage-wise for the general public out there, and would still keep the power inside the box. If you wanted to somehow power your circuit from within inside the Hakko box.
So that would leave the control board and the transformer energized and just disconnect the power to the heating element directly.
It's an option. Yeah.
Well, and to that note, I think also if you are to interrupt the temperature sensing circuit, I believe that the soldering iron will equally go into a failure condition and just give you an error message, or in the case of my analog soldering station, it would just blink the LED in a certain pattern.
Yeah, I think if it was for me, I would prefer just to have the whole thing shut off. I don't see any value in leaving part of it.
I also think the AC, cutting the AC, does make it more general purpose. So you can go and use it on any other iron you have or whatever.
Or your toaster oven, in case you're doing toaster oven reflow soldering.
Oh, I was just going to say, or as we prefer to think of them as a reflow oven.
Where are you going? Goodwill. Why? I need a reflow oven. Actually, where you guys live, you might actually be able to pick up a genuine reflow oven at a Goodwill.
That's probably true.
But why go there when you could start at a Silicon Valley dumpster?
Okay, so we talked about the control of the thing. How about the sensing side?
Well, actually, to clarify about the control, so again, right now there are 3 options on the table. Cut the power, cut the heating, cut the sensing.
Yeah, I vote for 1.
I vote for cutting the power. Like I said, it makes it more general purpose.
Yeah, and safer too. There's really no reason to leave it half on.
Nick, since apparently we're designing in the dark while you're actually solving the problem, does that gel with your design?
Oh, absolutely. If you go take a look at the Pignology website, I just listed this product for sale.
I'd like to point out that this is the difference between management and engineering. That while management is discussing the problem, engineering actually solved the problem and then forgot to tell us till the very end.
That's why I take my laptop into meetings.
Hey, 2 things. Does anybody on here have a Metcal soldering iron?
Yes, I do. I'm looking at one right now.
Is it one of those really fine pencil soldering irons?
Yeah, I got all sorts of tips for it, but yeah.
Man, I want one of those. That's like my grail iron. Sorry, tangent. I was.
Does anybody know anybody who works at Metcal and we can bring them on as a sponsor? Just real quickly, the Metcal MX500S soldering and SMT rework station, which is probably, I guess, one of the most ubiquitous ones, because when I Google Metcal soldering, that's what comes up. It can be yours for a meager $550.
That's hot. Hey, the other thing I wanted to bring up. Hey, George, we designed this product about 2 years ago.
We did?
I got the board in a box in my closet.
Oh, right. Oh, we did do it. Yes. I completely forgot about that.
There you go.
Yeah, there you go. So that's really funny. I completely spaced on that. Yeah, we put together did a project that essentially is a Wi-Fi connected AC outlet, and had it talking all the way up to the cloud, so you can press a button on the app on your phone and flip the relay on and off. Now, it didn't automatically turn it off.
That's just software.
Yeah, it's just software. That's the easy part.
So real quickly, I'm adding as an acceptance criteria, it does not interface with the cloud.
What?
So this is one of the things. No, you say this, but take a moment to think about this from a consumer product development design. And if you are a regular listener of the Amp Hour, you've heard this, but I had this opinion myself. If for some reason Google tomorrow decides that Nest is no longer worth it, and they spin that company off and they are bankrupt in 3 months, I lose the ability to control my heating and cooling because another company went out of business.
Okay, I get the point, but back up a second. Now, it doesn't mean that the only way to control your soldering iron is through the internet.
Okay, well,
all right,
way. Fair. Then my next layer of logic here is that I don't need this to become an IoT device, because then I don't want somebody to be able to surreptitiously hack into my home network and turn my soldering iron on and off.
This is why you don't come to Silicon Valley, Jeremy. You not to talk like that.
Well, they do have the internet where you live, don't they?
Yes, we do. But you have to understand that part of the thing that has made me incredibly successful in my career is I'm not the guy that comes up with the great ideas, but I am the guy who tells people why their great idea won't work.
Oh, so you're really popular.
Yeah, I am.
Oh, here comes that Jeremy guy again. Keep your good ideas to yourself. What you were saying?
I'll be over here. You guys just let me know when the show's done and I'll hit the stop button on the recorder.
Okay, so you don't want it dependent on the internet connectivity. I think that's reasonable.
Okay, so I'm going to go a step forward. I would be hard pressed to be convinced that internet connectivity is a requirement for this.
No, I'm not saying it's a requirement, but it's a nice to have.
Why is it a nice to have?
So you can get a notification on your phone when you're out buying milk that, hey, you left soldering iron on. Do you want to turn it off? Yes.
Or if while you're in phase, it can tell you to buy a new soldering iron because...
I've been on for 2.5 weeks. Go ahead and pick up a new one.
Well, if it's that smart, it should just automatically one-click order one off of Amazon and have it show up by the time you get home.
So what we're saying is don't bother building this circuit. Just get a dash button for soldering irons. So, okay, I'm willing to entertain this, but okay, so looking at the project, though, you're adding complexity of a wireless stack, some type of wireless communication protocol, and then introducing a new level of software.
You did not constrain the objective by saying it had to be stupid simple.
Well, here's another point to that. We are all wanting to build our own thing because we want to learn how to do it. And you can make it as complicated as you want to learn. Yeah,
what he said.
Well, no, I don't know if that was a comment in my favor or against me.
No, it's actually a fair comment, because if you want to learn how to do something like learn how to do microcontrollers, learn how to switch power on and off, learn how to program a Bluetooth stack, you can make this as complicated as you want it to. There's probably about 4 different levels of complication that we're coming out to.
And it may be that the soldering iron is not the one where internet notification is useful, but maybe something else that could use the same thing would be. So, for instance, if you're measuring the temperature of the soldering iron, maybe you don't need to know that it's on or off. Maybe you know it's always going to be on, but you might want to know when it hits temperature. Well, it only takes a minute for it to come up to temperature, so how useful is that? Maybe not useful, but maybe you have something else that could use this same contraption that would tell you when it comes up to the right temperature. And that way you can go about your business, do what you're doing, and then you get a message on your phone that says your thing is now up at the right temperature.
Or we could do something along the lines of take a general purpose Arduino testbed which senses something, and that something is yet to be defined. And then if something happens often enough for a certain amount of time, it will trigger the AC power. And then you kind of satisfies the general purpose reusable criteria. And then what you're sensing, whether it be, I don't know, temperature or current, is the next step.
So you took my point exactly. So there's the base platform of being able to control power based on some series of sensible inputs.
Mm-hmm.
And the platform, it sounds like, is extensible enough that could be integrated with any type of a network stack to get information into and out of the module, and
yes,
possibly even allow control over the network.
Yes. Keep it simple and add stuff on as you want to.
Okay. So let's draw this as a milestone then. Base platform. What are some of these? How do you guys want to characterize basically what Beric just said?
Well, I just said it.
Yeah, but I wasn't writing.
I would say the most basic system spec would be you need two things. One is you need a way to determine what the state is of the iron or the environment. In other words, whether it should turn on or off, whether it's a timer or a sensor. And then you need a mechanism to turn the thing on and off. So that's the most basic version. The fancier version might be maybe more exotic sensors, or maybe have it be internet connected or some other advanced feature.
Wouldn't the most basic version not need to know if the iron is on or off? If we've all agreed that the goal is to simply open or close the AC going to the iron, then remember the old Radio Shack timer things where you like pull out the little clip and you stick it in the time slot you want it to shut off? It's similar to that. You push a button to turn it on, and then 30 minutes later it turns off. Does that device need to know that it's actually on?
A 555 timer with a 30-minute time constant.
So what's funny, well, what I was going to say, Nick, to your point, what's hilarious is one of our listeners, Nate, N8HWV, actually sent me an email that said, you're overcomplicating this. Here's a $12 or an $11 thing from Amazon that is basically an egg timer with a socket on it.
That is not fun.
No, it's not. But
and I said, we're building this because we want to learn something along the way. That's why we're trying to make it complicated.
Well, and Beric, I was trying to kind of pull on the, your point that there is a base core set of functionality that can be abstracted from all the rest of it, which is, redescribing it is that you need to be able to control AC on or off based on some measurable condition that's electrically measurable.
Yes. Okay.
The network is bonus, or are we calling that part of the base platform?
Well, there's a couple levels of abstraction when it comes to connectivity. I mean, we have internet connectivity or local wireless connectivity via Bluetooth.
I would put that in you have the ability to add that on afterwards, but I would certainly not put that in the core.
I'm just adding it as an abstracted layer to Nick's point called connectivity. And because the reality is, and it's what's interesting is I'm wondering how many of you out there, at least in this round table, are actually thinking about, I'm going to go get an AVR something and, build a board around it versus, somebody like me who's going, I'm going to go get an Arduino, or I'm going to go get some, an STM something or an ESP something, or not an ESP, but I'm going to go get some microcontroller and I'm going to build this stuff around it. I mean, at the heart of this, there is still a microcontroller, right? We're agreeing it's a microcontroller project, not a single board computer project, not a Raspberry Pi project.
That's what I would do, although I'm sure there's a lot of other people who would approach it differently who are not comfortable with programming microcontrollers. So I think for this particular problem, like Beric suggested, you could solve the problem with an integrated circuit that's a very simple timer. You could solve the problem with what Nick suggested, which is a mechanical timer. So it's not necessarily grab the Arduino as the solution. That's how I would do it because that's what I'm familiar with. And I could see the flexibility in doing it that way. But I think a lot of people who don't have that knowledge won't do that because they don't know how. And I think that's something that would be great to learn.
Well, hopefully that's what they're doing by listening to us right now.
So, which kind of brings up a useful side question, which is, why would that be a good idea? So if I can solve the problem with an $11 mechanical timer, why would I solve this problem with software and a microcontroller, even at the same price? I think that's a reasonable question. And, certainly if the goal is just to solve the problem and move on, then perhaps you don't need that complexity. But to Beric's earlier point, this is a good exercise in learning other stuff that you can then apply to problems that are much more appropriate to a microcontroller's kind of what it could do.
Well, I think you nailed it right there, George, is that, for me, this was an excuse to learn something. Another part of it really is if you go back to the very beginning when we, in the very first episode, we talked about the more creature comforts and conveniences you can build into your workspace, the more you're going to work in it. You're not going to come in one day, be mad that you have to bend under the workbench to push the button on the egg timer socket and be like, screw this isn't worth it. I'm going to go spend $300. Because and to me, that's why I had one of the nice to haves is I really don't want to have to go into the bench every single time, to do this. And like somebody mentioned earlier about the dead man switch is if you were to power it off the thing, and well, it's like the useless machine, right? You turn it on and it turns itself off. But then there's some type of physical resetting that may have to happen unless you introduce a discrete power supply for your micro. That's, and you have another cable running up onto the workbench or something.
That's why I was against the cutting the AC power as the solution, because it would be nice to take the 5 volts or whatever to power your circuit from within the iron box itself.
Well, yeah, if you could take all of your control electronics that you're introducing to the problem and somehow wedge it into the existing case, yeah, that would be great if that's possible.
Well, or even use the box as its own power supply, as the power supply for your circuit.
And and to that point, you could technically rewire it so that the transformer is always on and that the switch actually is between the transformer and the internals.
Yes.
Now by the
way, we've been talking about the main controlling thing as time, whether it's a mechanical timer or maybe a software-based timer or an IC timer. But there's other ways to determine whether or not the thing should be on or off besides time.
Well, before we jump down that path, because I don't feel like we've come to an answer. We've agreed that we're abstracting out the base platform, which is a microcontroller-based design for the purposes of this exercise, that has a way to determine the state of some condition through sensing, and then a way to modify power on and off. Is that what we are collectively going to agree on the way forward?
I'd go with that.
Well, that's the way I would do it.
Nick?
Yeah, count me in. I'm good.
Okay. So,
did you get the board back yet?
The problem is it'll take Apple about a week to approve the app. So we'll start that. We will come back to solving what those pieces are. We've kind of covered those already. There are commercial products that you can run a signal line into, and they will turn things on and off. And then you can all go all the way down to the componentized relays. And you can get some of these AC relay boards for as cheap as $3. In fact, even Micro Center carries one by Sane Smart that has 2 circuits on it that I think was $295 or $395 that would do 120 volts AC. So we'll set that aside as far as the particulars, but we also know the microcontroller will be at the heart of that. So now the next part of the problem is that we've decided how we're going to control power. Now we have to talk about how am I going to determine how to control power. I started off with the concept of a timer because to me, that is probably the constant that is going to pass by that I will determine, hey, I'm not using this anymore. Some amount of time has passed. But we haven't talked about how to tell if it's still in use, etc. Because to your point earlier, George, we definitely do want to consider that you don't want it to just turn off after 30 minutes. Like that's not the most practical thing when we are using a microcontroller.
You could have a switch somehow in the stand that the iron sits in, so it can tell when something's being lifted out or put back in to reset a watchdog.
So that's like a micro switch.
And that's actually how, if you buy the $300, I think it's like the 932, I don't remember the model number, but that's exactly how that works. Is in the cradle, the socket that you put the pencil back into, when you put it in, that weights the thing down and that hits a micro switch. And then there's a cable that runs from the soldering iron, the pencil stand, back to the main body.
Dude, I just had an idea. How cool would it be to say, Alexa, turn on my soldering iron? All right, sorry. Go ahead.
The way I would do it, not using Alexa, would be to monitor the voltage on the temperature sensor and kind of see rapid changes in that, and then use a rapid change in that to reset the timer. That'd be the approach that I would decide to dig down.
To take a look at what again?
It's got a temperature sensor in there, so you've got your iron, and in a steady state, it's not going to be changing that much. But as soon as you use the iron, like you stick it on the ground plane or some leads to actually solder something, the temperature is going to drop.
That's an interesting one. I think that would require a little bit of analysis. So I think you have to look at what that sense line is, and when you go to use the iron, see how detectable that temperature change is. If you're using a very fine tip pencil, and you're soldering, let's say, a typical component lead, I doubt that's enough of a heat sink to draw the temperature of the tip down much. If you're touching it to a big ground plane, yeah, perhaps. But I don't know if you could detect the temperature shift just from one little solder pad.
Well, in the along the lines of just learning something, that's the approach that I would take until I gave up on it and found something else. Now, I noticed Nick just posted a board layout into the document that we're talking about.
Yeah, I'm not going to take credit for that. George just was...
Hey, that looks familiar.
I think I did the left half, or the left quarter.
Yeah.
That looks like it's set up for 2 relays.
Yep.
That's hilarious.
Oh, talking of relays, do we want latching or non-latching? Because if we energize it with the... using the Arduino or whatever, and then the Arduino suddenly lost its power, then the relay would close again and you'd have a bit of a loop.
I think I would use a non-latching relay because they're less expensive and there's really no reason to keep it in a particular state and reduce the current draw on the relay. If the whole thing was DC operated, then I would, maybe. But being that it's AC operated, I don't think I wouldn't bother.
But that's just something to consider for the person listening at home who's designed something and then thinks, that shouldn't have done it that way because I don't have any power to power the relay to keep it off, etc.
So going back to sensing, am I still soldering? I mean, if you look at it from the perspective of what are the things that are happening when I'm actually soldering. So I am most certainly taking the pencil out of the stand. I am definitely, moving it back and forth. I'm probably running it into the brass brush or the sponge to clean it along the way. So what are some other opportunities we have to sense, the state of use? One that comes to mind for me is potentially using some type of an optical sensor to determine, like if a beam is broken, or even one of those inexpensive ultrasonic sensors to determine, hey, the tip is moved out of the cradle, therefore reset a timer.
Yeah, I was thinking the same thing, actually. Not the ultrasonic, but a little IR receiver transmitter and put it on either side of the handle. So when you pull it out, similar to the micro switch approach, but when you pull it out and now the sensor can see the IR diodes emitting light, then it knows that the handle is pulled out of the cradle. So I'd probably do something like that, which would be external to the to the whole gadget.
Which, so to your point, that would require running leads from the cradle to somewhere.
Right. Now, if the off-the-shelf controller for the soldering iron is big enough and you can slip a little microcontroller in there, you could just have that all inside the box, like Beric was suggesting, and power it off of the AC and just have those few leads coming out to the IR transmitter receiver. So it could be pretty clean. It doesn't have to be a bunch of extra wire.
But if you did that, you still have a physical connection you're going to have to make from the cradle, which today has none. And then you would instead have your leads running back to whatever the switching mechanism is.
Oh, well, in the case of your Hakko, that's right, because the thing that the soldering iron rests in is not physically the same thing as your transformer boxes. So in the case of my Weller, it's all one unit. So depending on the soldering iron, yeah.
I have just thought of a reason why it would be a bad idea to have the read relay or the micro switch in the base. What if your iron falls out when it's not being used and is just lying on the carpet?
Then that would violate the acceptance criteria of not burning the house down.
Yeah.
Good call.
But so now you need a toxic fume detector to see when your carpet is melting and putting out.
So what Beric, what are your thoughts on the, optical sensing or some type of motion sensing on the pencil going into and out of the cradle?
I kind of think that's overcomplicating it. I don't know. If you want to learn how to use an optical sensor, then go ahead and do that. I know the way I tend to use a soldering iron. I don't always use the cradle. I sometimes even just have it resting on top of something, but if I'm just using it, that's just the way I use it. And I can't be the only one like that.
Yeah, but don't you have a Metcal that doesn't get hot until you're trying to actually solder?
I do, but it still gets hot. I mean, you could still burn yourself with it.
Okay,
If
fair.
you tried hard enough.
So what so we've talked about some type of micro switch, which we actually have just debunked. We've talked about optical sensing. We've talked about sensing on the monitoring the voltage, going to through the temperature sensor. What other opportunities for sensing the condition of quote unquote use do you think we have?
You remember the old school thermostat mercury switches?
Oh yeah.
Yes. Just strap one of those to the end of it, the other end, where the wire comes in. If you're moving it, then each time the mercury closes the switch, to reset the timer.
It's interesting, joking about this, but there are now there are equivalent switches, not even looking at like gyroscopes on a chip or anything, but there are motion switches available in ICs.
Even though I mentioned that, I do sort of fall on the side of the fence where Beric is, that is kind of overcomplicating. If whatever thing is created, let me know that it was about to turn it off, and I had to take an action like push the easy button to restart that timer, I think I'd be okay with that.
So that's like a dead man switch.
What if you had to pull your phone out of your pocket and log in? Type in a code and
I wouldn't want to do that.
Yeah.
So then that idea is that say this device by default has a 30-minute timer. You get 25 minutes in, it starts beeping, you press a button to reset it, and it's like, I'm safe for another 30 minutes of soldering.
It sounds exactly like the Metcal I have at work.
Really? So
we get it. You have a Metcal.
Yeah.
Well, I have no. This is the one at work, which is
you have two Metcals.
Was that a condition of employment?
Yeah.
So it doesn't have a reset button. You don't have to whack the thing every hour to make sure it's still alive, do you?
It starts flashing. The screen starts flashing away at me and tells me it's going into a saving power state. And
how do you reset that?
There might be a simpler way, but I just toggle the power switch. Which is right on top. I don't need to go digging down under a desk or anything.
So Metcal, one of the leading manufacturers of soldering irons, their method of resetting the timer is off on.
There might be another way. I don't know.
Maybe there's a $500 option if you want it more intelligent than that.
There's a hand wave available.
Nick, do you read manuals for things that you get, or do you just throw them out with the styrofoam?
I read them.
I don't.
Speaking of
hold on.
Right.
I have to comment on this. I know for a fact George does not read manuals, because one of the first times you and I were on a podcast together, I informed you that your Kenwood TH6 had a sideband receiver in it.
I will never live that down, because I emphatically told you it didn't.
You were absolutely no, it doesn't.
No, it doesn't. It does not. Boy, you really schooled me that night.
Yeah.
You know That sideband receiver is the reason I bought that radio, but I have yet to ever actually use it.
Well, since you own...
You and everybody else.
You own one Kenwood sideband HT, you should go ahead and buy the new THD74.
When I have the price, maybe.
You are a ham.
Yeah.
Did you order yours yet?
No, I have not. There are things that... there are purchases I want to make for our coverage of Dayton next year that are more pressing to me, because that would actually benefit the listeners.
You going to buy a Metcal soldering iron?
And I'm going to lug it around Dayton, offering people to solder things for people
with a microphone.
I'm going to be trailing I'm going to have a power film solar panel or solar array, 240 watts of power film solar dragging behind me with a Samlex 1200 watt pure sine wave inverter.
No, you need the butane powered solar pen.
I noticed actually Micro Center carries. I saw they had the Hakko version of that. I'm sorry, Nick. You were talking about hand waving.
Yeah, passive infrared on the box, where motion detection. So it beeps at you to say I'm about to turn off, and you wave your arms, and kind of like when how the light turns off in the bathroom at work sometimes.
Yes.
You wave your arm and salvation.
Unless you're in a stall.
So you wave your arm in front of the PIR detector, and then it resets the timer. You see how I got myself out of that conversation?
Yeah.
As long as the PIR sensor isn't actually fooled by flames.
Or a heat source like, I don't know.
A fire.
A soldering iron.
Well, okay, if we're trying to be inclusive, that's another way too. You could probably put a thermistor somewhere near the tip of the soldering iron to measure temperature as a way of detecting usage.
Isn't it supposed to be on if you're using it?
But do you mean in the actual stand cage thing?
Yes, yeah. I mean, that's in other words.
Again, I don't quite understand that. What was the idea?
So in other words, the tip goes into the thing, right? There's radiant heat coming off of the iron. If I put a thermistor above where the tip would normally go, and I start noticing temperature fluctuations in that tip, I can infer. And again, this would require analysis.
If you pull the pencil out of the thing, then
it will cool off.
Oh, right.
Unless your iron is temperature controlling itself, so the fluctuation actually happens naturally.
Is that something
no. No, actually, what you can do along those lines is you just put a temperature sensor by the tip, and what you're really looking at is the difference between ambient room temperature and something really hot.
Yeah, because when you pull it away to solder, I mean, you're going to have maybe a 10 or 20 second period where the radiant heat from the tip will have been removed, and you will see the temperature drop well below whatever you have the soldering iron set to.
Out of all these ideas, I like that one the best, because it's one thing. It's not like you need a receiver transmitter, and you just have to localize that sensor probably within a half an inch or so of wherever the tip rests in the holder. That'd be pretty cool.
True, but I actually like the PIR idea better, and it didn't occur to me that they actually make devices that are both the emitter and the sensor in one discrete unit. And the reason I'm saying that is because there is going to be some research to be done. Number one, trying to figure out how quickly does the sensor cool off, and you're going to have to figure out what is the optimal spacing of the sensor from the tip. Invariably, you're mounting it above the tip, so that has the potential. Well, actually, no, it wouldn't interfere when you put the holder back in, because at least with the Hakko, you can only put the pencil back in one way. Like the tip passes through a hole, so it's not like you run the risk of like hitting that sensor every time.
Mm-hmm.
And also, would there be any penalty in it turning itself off if the iron wasn't put back into the tip? Because your fault condition is the iron being left in the stand for 2 weeks. But if the default was the iron is in the stand and then you take it out and it doesn't go back into the stand for 10 minutes, wouldn't that be valid reason to turn itself off for safety reasons as well?
It would be, and so that's something that both the temperature and the PIR sensors give you the option to, right? It can detect both states. In other words, it would work if I could sense if the beam has not been broken or unbroken, whatever. If I'm not detecting movement for 30 minutes, shut it off, and that works either whether the pencil's in the thing or the pencil's out of the thing, right? And then same thing with the temperature sensor is, there are two logic paths. If I have seen a consistent temperature of over 300 degrees C or whatever it is, or just a consistent, actually, if I see a consistent temperature for 30 minutes, turn it off.
Whatever the temperature is.
Whatever it is, yeah. And then you would have some other logic in there to be able to do, a little bit more, it's like, oh, I saw the temperature dip, however many degrees, and then it went back up. That would tell us that it's being used. But if you saw the temperature just continue going in a single direction and then stopping, then that works both directions too, whether you left the iron on your bench or you left it in the cradle.
Well, speaking as a hardware engineer who's come up with this, this conundrum, talking to software engineers before, when you say a constant temperature, there's no such thing as a constant temperature when it comes to hardware.
Oh, I spent a lot of money getting the entropy out of my workbench. I don't know what you're talking about.
Yeah, but staying within a range. I think we should make that clear. It's not. Yeah.
By the way, I think a lot of these parameters, like if this and that and this range and whatever, are all arguments for why a microcontroller is, in a way, the easiest way to set this whole thing up, because it's relatively easy in software to read multiple inputs like switch closures and temperatures and so forth, and then decide in the software, if this number is above that number but not above this number, then do this unless it's Tuesday and all that. It's really hard to do that stuff in pure hardware. And it's much easier to do that in a dozen lines of software.
And we also don't want we don't want to wait 5 minutes for a Raspberry Pi to boot up. So,
especially when there are a lot of failure conditions that occur that could prevent the Pi from booting up.
Yeah.
I mean, every generation of Pi, the things become less, voltage variation tolerant. So I think we've done a good idea laying out what the base solution is. We've kind of dug through the sensing. Why don't we take a break, and when we come back, we will pick back up. So this is Jeremy KF7IJZ with George KJ6VU, joined tonight by Beric K6BEZ and Nick N3WG. We'll be right back.
The Workbench is sponsored by our friends at CADsoft. They're the makers of the Eagle PCB design software, the very software George used to design the Pactena Classic, Pactena Mini, what him and Beric are using to create this new antenna analyzer project for you here on the Workbench. They got hundreds of parts libraries, tons of reference designs, and a monster huge user community. Eagle's a great choice for your next ham radio project, and you can get your free copy of their software today. Click on over to cadsoft.io and start getting your project put together today.
All right, welcome back. I am here with George as usual and our special guest Beric K6BEZ and Nick N3WG of Pignology. So at this point, we have decided that for this project, the way to make the soldering iron into a safe state is to cut power to it. We've decided we're going to use a microcontroller to control that as well as be responsible for sensing. So there is a software component. And then we went through many different sensing options, for everything from putting a micro switch in the stand to detect the physical presence of the iron, to using some type of a heat sensor to determine whether, the temperature has changed in a while to, decide whether or not to shut the thing off, to something simple where there's just a dead man switch that will require you to push it every 25 minutes with some type of an audible warning. At the end of the day, we are kind of circling in on a solution where there is going to be some type of a box somewhere. It sounds like we have completely moved away from the concept of putting in something inside the soldering iron, and truthfully, probably not even interfacing with any of the electricals in the soldering iron. Do we agree on that?
That would definitely keep it more general purpose, and you could use it with any iron rather than just this particular one. So okay. I agree.
Yeah, I did just think of something. One of your acceptance criterias is solution does not become so unwieldy, tangled in the cabling and whatnot. If the thing that we're proposing goes between the wall outlet and the cable, the plug at the end of the attached to the soldering iron itself, and then we want to run something from this device up to the iron receptacle, then we're talking about we got about 6 feet of wire there where the box is going to sit, and then we got to run something 6 feet back towards the receptacle. It's starting to get a little unwieldy.
That's true, because then we're talking about some type of a physical connection from the soldering iron stand or cradle going back to wherever the microcontroller is going to live, and then possibly another box actually controlling the power. Because I guess in my mind, it probably was a 2-box solution. 1 box to actually be down by the plug that's controlled, and then you would have a power line that you could wrap around the cord of the soldering iron going up to the actual microcontroller box, and then another lead from that to the stand, which I know sounds unwieldy, but I think you could keep that tidy. Like having a single 2-conductor cable coming off the back of the soldering iron cradle, to me does not count as unwieldy.
Yeah, I think that's reasonable.
Yeah.
So back to Nick's point, though, where do you want to put the microcontroller? Does it make sense to actually put it all in one contained unit down on the floor near the plug, and then only have 1 cable running up to the back of the soldering cradle? Or do you do like I suggested, where there are 2 boxes? What do we think would be best?
I'd want the reset button or whatever to be not down on the plug strip on the floor. So something in line where you had it plugged into the floor, and then that came up and it sat on a desk by your soldering iron. And then that had an AC outlet on there where you would just loop your soldering iron into. So you're moving the wart down from the floor to an inline thing right by your soldering iron. That would be my thought.
Let me throw something else in there. How do you turn the thing on to start with?
You hold the button down. A push button on the top of this separate box.
Okay, because we didn't talk about an on button before.
That's a very good point.
So you need some way to initiate the thing working.
Well, and just to kind of clear, earlier when we were talking about this, there was if it was running off power in the iron itself, if I turn the iron off, it shuts itself off. So I think we are presuming that our solution is going to be externally powered from the wall.
Yeah, right.
So some type of like a little USB power supply.
Or it could be built into your relay box.
So, and that's actually still something we haven't really talked about in depth is, do I have a relay box, or am I using one of these pigtail devices that George found on Adafruit?
I think if it were me, I think you could do it multiple ways. I like the idea of an external box where all the AC is insulated from you or your dog getting across the contacts, and have that be low voltage controlled from the microcontroller, which means there's probably 1 box which is interrupting the AC to the soldering iron, and then you have a second box which houses the microcontroller, and really not much else. So that second box has the microcontroller power. Well, the power adapter could be like a 5-volt AC power adapter that you plug in separately. And then you need the sensor input, and you need the power on button.
What if your circuit power supply got unplugged and the soldering iron was still turned on? What behavior would you expect then?
Well, of course, you want the soldering iron to be off. So back to the latching or non-latching relay. If you use a non-latching relay, when the power is off from the microcontroller, then you'd want the power relay to the soldering iron to de-energize, and so not be turning on the soldering iron.
Because where I'm heading from this is you've got your 110 iron plugged into the wall. It goes through this wart that you've bought off Adafruit. It goes into the iron. Then you've got this separate microcontroller box which is powered via a USB line voltage to USB, and that feeds into your microcontroller. Well, what if someone was to unplug the microcontroller because they wanted to plug their phone into the USB power supply?
So that's what I was just saying. So what you'd likely have coming off the microcontroller is a buffer, essentially like an NPN transistor, open collector pulling the relay to ground. So you'd supply voltage to the relay, and then pull the other side of the relay to ground. When the power to the microcontroller goes away, then that transistor would float which would de-energize the relay, and so no AC power going to the soldering iron.
So the default is iron off. The failsafe is iron off.
Of course, default is power to the soldering iron is off. So which means the only way to turn on the soldering iron is you got to have the microcontroller plugged in, and then you have to press the on button to then engage the power relay that turns on power to the soldering iron.
So the soldering iron switch is permanently left in the on position.
Right. And your failsafe is if the controller's power gets pulled for some reason, then the soldering iron goes into the off state automatically.
So, because again, I'm looking at this from the perspective of there's something to me very nice about, spending anywhere from $10 to $20 on one of the Adafruit feathers. And if you go to the $20 route, you can actually get an Arduino that has Wi-Fi capability, which would satisfy, that would get something that Nick's
app. Who wants network connectivity?
It would keep Nick happy. Yeah.
It would keep Nick happy. But I mean, that is an option because there are wireless, and there's even other wireless, like traditional 440 and 900 megahertz data radios, high-speed data radios. There's all kinds of wireless connectivity options. I think there's even one that has an option for an Ethernet port. But I like that. And then if you have the separate relay, where you could actually put the relay and the micro physically in the same box, and that way it's still all disconnected. You don't have bare power leads out. And overall, like I said, for the price of just the 4-port, the 4-port pigtail you had mentioned, I'm getting the microcontroller in a relay. And for this particular instance, I think I only need the one relay.
Yeah. Can I float an idea by you guys?
Of course. That's why you're here.
Because I don't like any of this. This is just stupid.
Tell us what you really think about it.
Biometco.
So you were right, George. This is representative of a true work design session.
I was recalling that commercial where that guy is like, "No, it's a stupid idea." Anyway, so there are off-the-shelf electronics enclosures that are in the shape of a wall wart and have the prongs, meaning the AC outlet prongs, already installed. If it were me and I was designing this as a product to sell, right, I would take one of those things and stick a board in it, tap the AC to power the electronics. So AC to DC, get it down to 3.3 volts and power the microcontroller. And then the AC passes through a relay that's also in that same wall wart box. Coming out of the box is, just to make things easy, probably a 3-conductor AC receptacle on wire that's clamped onto the board on the inside of this wall wart. So the end user package is a black box that they plug into the wall, and hanging out of the bottom of that box is a 3-prong AC receptacle.
Plus a plug to go to the sensor in the cradle and a button to route up to the desktop.
I was getting to that point.
Sorry.
Thanks, man. But putting it all in that one single box, then you don't have to worry about. It goes back to the tangled mess of cords. It's like the pigtail thing you put in line, and then you got to run the trigger wire up to another box that has the electronics in it. Then you got to worry about powering that box itself. I think it would make things a little bit easier if we could just tap straight off the AC directly at the outlet to power the electronics, and then have your little cables coming out for the sensing. Just an idea.
That's a good idea.
And then what I would do is on the board on the inside, I would put either assembly or a particle. What's the name of the Wi-Fi one, George? Photon?
The Photon,
yeah.
Or an electric imp would make things stupid easy because they already have the cloud available to you. What's the other one? So assembly is Bluetooth. These other two are Wi-Fi. And you can put the smarts, the actual microcontroller smarts, in the chip itself. So you don't have, a PIC and then a transceiver. It's all just built into the thing, and you write the code on there. So I would use the RF module as the actual microcontroller itself. Then all you would need is the relay and the transistor and whatnot to actually flip it.
So amongst those, I think the Photon is in a way the most interesting one to me, because the Photon is about $19. It's an Arduino compatible microcontroller. So if you're familiar with Arduino code, you can program the Photon pretty easily. And with their cloud service, which is free as a hobbyist for some reasonable amount of usage, you can also connect that to IFTTT. So IFTTT is a kind of a cool web-based service. It's if this then that, and they have connections to tons of different data sources. So you can do things like if I press the button on my phone, then flip the relay, or if it's Thursday, or if the weather is rainy, or if my stock price goes up or down, that do this or that. So you can do some pretty fancy conditional stuff without having to do a lot of coding.
Such as, if my Nest thermostat says that I'm away, then turn off my soldering iron. Yeah,
exactly.
So one thing this goes back to my part about the cloud, is that the thing, because I have seen some really cool applications for the Photon with some folks at work. But my concern is, if Particle folds up shop, you can't program your board anymore, because and your $25 hardware investment in this project will be for naught. Yeah. But I mean, you joke about that. But number one, I just asked Beric if he was going to buy the most advanced HT ever, and he said yes, when it cost half as much. Hams are cheap by nature.
Okay, well, rewind back for a sec. Okay, so let's seriously, let's say you use the Photon and it's Wi-Fi enabled. And if tomorrow IFTTT or Particle fold the tent, okay, you don't have the internet connectivity part, but you still have a running Arduino compatible microcontroller that could still be looking at a sensor, and you do everything locally. You don't have to use the web. It's not a requirement. It's another data source. So you could say, for example, if the Nest temperature sensor, thermometer system detects that I'm not home, shut off the thing. Or if one of the other things we talked about, the IR thing is tripped, or the temperature sensor is sensing something, then also turn it off. So it doesn't have to be one. It could be multiple different things that qualify to shut the thing off.
Oh, I got one. If the Bluetooth sensor in this particular device that you're using senses that your phone has been out of range.
Good one.
Say that again. If you're out of range, then it shuts off.
Yeah, if your phone is not with you, I mean, I keep my phone with me all the time.
Mm-hmm.
So if you go and leave and you take your phone with you, then so the sensor kind of says, Beric's phone hasn't been here for an hour.
Well, the funny thing is, you've also inadvertently come up with a security feature, because it'll only work if your phone's in range. So that way your kid can't turn or your dog can't turn on your soldering iron while you're away.
Nick, I'm actually doing you a favor. I'm actually putting Bluetooth into this without going Internet of Things on it.
Yeah, so I'm cool with the whole no cloud thing. There's both sides to the thing, but going back to the assembly idea, assembly is also Arduino programmed, and libraries are available for iOS and Android and whatnot. Extending on Beric's idea, what if when you walk up to it, it turns on?
It says, "Hello, Nick."
Yeah,
because of the Bluetooth.
Yeah. It's so this thing. I mean, we got unlimited power coming out of the wall, right? So it could always be on and sort of looking for the phone to connect to. If it sees your phone, it turns on the soldering iron.
Yeah, but you see, you wouldn't want to do that, because, like, case in point, I'm sitting about 6 feet away from the soldering iron right now, and I do not want it on while I'm recording the podcast.
No, but you do it the other way around, which is like, it doesn't automatically come on, but it automatically shuts off if you go out of range.
Yeah, no, we talked about that. That one makes sense, but my point is they were just talking about having it automatically turn on.
Yeah, because if the iron is out and like lying on the expensive carpet that we mentioned earlier.
All right, don't do that one.
Yeah, you walk into the room. Yeah,
but the walk away one. Yeah.
Real quickly, I want to go back to the particle because the particle is the particle photon is based on an STM ARM chip, so it's faster, more powerful, more memory than the traditional Atmel chips, AVR chips that are in like the base Arduinos. One of the things I just want clarification on, I was under the impression that the only way to program it was through Particle's cloud services. Like I didn't know there was a way to locally program it.
Yeah, I bought one at Maker Faire 2 years ago, and that's the conclusion I reached. So it's just sat unused in the box since then.
But that's not correct. So
Okay.
you can download the IDE to your laptop and install it and do everything local without the Particle Cloud compiler. However, it is a royal pain in the butt to install it. So they don't make it easy, but it's doable.
Yeah, you can push code over USB on it.
Okay, so that was correcting a gap in my knowledge. So
Basically, like it uses the GCC compiler and a bunch of other stuff. So you have to make a bunch of things and configure a bunch of stuff. And it's not like click, download. Oop, there it is. It's all done. It's not like that at all, but you can do it.
Is it compatible with the Arduino IDE?
Yeah. Well, with the IDE, is it source code compatible? Yes. For the most part, it is source code compatible.
But you could use the Arduino tool chain to actually write software to it.
Well, so you use their flasher to put the firmware into the device. So I don't think you can use the actual Arduino IDE to flash it, but any code that you write for the particle is pretty much the same as vanilla Arduino code. The reason I equivocate there a little bit is that there's features in the particle to talk to their cloud services and stuff like that. So if you use any of those features, of course, it's not in the normal Arduino IDE. But for example, I've made a particle read a temperature and humidity sensor, and I just searched the internet for Arduino code for this particular device. I found an example, cut and pasted it, compiled it for the particle, and it just worked. So
it's the same language, different tool chain.
Yeah.
Okay. So at this point, I mean, just while we had a little break in there, did we get consensus on the best sensing option for, the state of use for the soldering iron? Temperature versus like PIR?
I don't think we did.
No.
So are the two best options on the table the temperature and the PIR because they would allow you to sense, they don't require the iron to actually be in the cradle to still be effective?
I don't know. I think you really want the iron back in the cradle, and then have some way to know that it's not been used for a while.
Yeah, but I mean, at the extreme, imagine that somebody is soldering something and they have a massive heart attack in the middle and they keel over backwards and pull the iron with them and it's just dangling in the carpet.
Mm-hmm. Right. And at some point it should shut itself off.
Yes.
And
so I'm guessing their phone's not going to walk away in that scenario.
You are hell-bent on involving RF in this.
Well, if the iron did actually start burning the carpet, the smoke alarm might actually summon some aid for the person who's had the heart attack.
All right, so there's your use case for including back to the IFFT option, is that if my Nest Protect detects a fire condition, much like my heater and my air conditioning and all that, it can shut off the soldering iron.
Right.
Well, no. I'm thinking of the poor sod who's on the floor, who's clutching his heart. No, if no one's seen him, but the actual Nest detects the fire that the soldering iron caused, then that would summon help. So the fire could actually save the person's life.
I think we need a disclaimer at this point that says this is not for life protection.
Yeah, don't build that part of it at all. Do not rely on this. Don't even rely on it to shut your soldering iron off. We're not suggesting you do anything that we have suggested here.
This is what happens when meetings go long, folks. Yeah.
Well, if somebody had come to the meeting prepared by having read the materials, So what do we recommend as the best way to sense? I mean, it seems we have really centered on the best way to sense usage of the soldering iron is going to be its placement in or out of the cradle. Can we agree on that?
I think we can if we want to move this along. I mean, no, seriously, it depends on what approach that you want to take, and I would say it is a valid approach. There are other valid approaches, but this is a valid approach.
Yeah, because I mean, you could even get into you have to insert a physical key attached to a wrist strap or something, which actually some of their higher end stuff do have that feature. The iron won't operate without the key. Okay, so
like a jet ski.
Yes, exactly. So what happens? So what do you guys recommend as the best way to detect presence in cradle?
You know, of all the ideas, the one that I like the best is a temperature sensor near the tip, because I think it's fairly easy to detect the presence of the iron, which is probably going to be in the 600 to 800 degree range at the tip from the ambient room temperature, which is going to be closer to, 70 to 90 degrees or whatever. So there's a huge temperature differential. So, and that seems like mechanically it'd be pretty easy to locate a temperature sensor there.
Well, I just found that there is an entire selection of contactless infrared temperature sensors available on Adafruit.
Yeah, actually don't even, you could do that, or use a traditional temperature sensor like an LM35 or a 18B20 or any of those commonly used ones that come in little transistor cases.
Or a thermistor.
Yeah, the thermistor is certainly, you could do that too. It's just you need to build a little driver circuit for the thermistor. But yeah.
So George, I am curious though, why do you prefer the temperature sensing over the PIR?
I don't know. The temperature sensing thing, from experience, I know that the temperature sensor would work, I think. Whereas the IR thing, it's not so obvious to me how it would. I guess if it's just sensing heat IR as opposed to like motion IR, I think that'd be fine. I don't have anything against it.
Nick, to you for a rebuttal?
I would lean towards the those self-contained 18B20 things. The probes with the leads already on them, or the header already on it. Simply because wherever this box is sitting, a little hole that has the 3 pins that you just plug the probe into and then run the probe up and scotch tape it onto your cradle would probably be easier.
The galvanic sensors that you stick into temperature probes, temperature sensing boxes, you mean?
No, I'm talking about what's the best way to describe it, George? It's like a little metal cylinder that houses an 18B20 sensor.
Yeah, exactly. It looks like the end of a pencil. It's about 1/4 of an inch in diameter and about 1 inch long. It's a metal cylinder, and inside the cylinder is the temperature sensor, which in and of itself, if you just saw the temperature sensor chip, it's in a little TO92 plastic transistor case with 3 leads coming out of it. But you can buy those things where that little plastic transistor case is shoved into a metal cylinder, and like Nick described it, the other end of the metal cylinder, the open end, will have a wire coming out of it, a 3-conductor wire, and that just routes back to your microcontroller, and you provide it ground, power, and a 1 pin for data. And now you can read the thing. The beauty of that is that temperature sensor is a digital device, so that it's not an analog value that you have to calibrate and read. It's sending you data from the chip in that cylinder and will tell you the actual temperature.
So here's something that may throw a wrench in that. The temperature range on that device is only to plus 125 C, and when the average temperature of the iron is going to be around 350 C.
Not a problem. It's not a problem because you're not going to contact the temperature probe to the tip of the iron. So there's going to be an air gap between the iron and the sensor. And I guarantee you that the air temperature, an inch or two away from the tip is not 800 degrees. It's going to be much lower. And all you're really looking at, you're not even worried about measuring the actual temperature. All you want to know is the temperature about room temperature, or is it like off the chart? If it's off the chart, then the tip is within range.
Well, if you talk about this being a metal enclosure, I think there's an assumptive hypothesis there that the iron has been out of the holder long enough to get below 125C. And that's the only reason why I was concerned about the temperature limit, because like if you're just doing a quick soldering thing, like the thing that led me to doing this is I was fixing a cold solder joint on the charger for my Titera DMR radio. So the soldering operation itself lasted all of 3 seconds and then went right back in the holder. And I don't know if that's enough time to have actually let that thing cool off enough.
It doesn't matter, because if the soldering iron is in use for a couple of minutes or 10 minutes, and then comes back, it's still all in operation. What you really are looking at is the temperature constantly high for a period of time that's longer than you want the thing on.
Yep.
And what's the worst case that could happen in this scenario? The iron turns itself off because it doesn't detect your 3-second solder.
Right, exactly. So, and I think there's certainly some experimentation required here to figure out how far away from that tip does that temperature probe have to be. And which is something we could actually test very easily. And I'm kind of curious myself, but I don't know if it has to be 1/4 of an inch away or 1.5 inches away or whatever, but it's something like that. And
okay.
So like for instance, if you look at on my bench where the Weller soldering iron goes into its stand, there's like the coil that is surrounding the tip. If you have a wire that's sort of draping over that little coily thing, it's not, you wouldn't do it, but it's not going to melt the wire. And that's only like 1/2 inch or 3/4 of an inch away from the tip. So I suspect that the temperature, the ambient temperature within an inch of the tip is not that high. So you can probably get fairly close to the tip to detect the increase in temperature. So anyway, worth an experiment to see, but I think that would be a one reasonable way to do it.
And those parts are available for like $4 a piece. So that's pretty cool.
Yeah.
Okay.
Yeah.
So
once you've got the microcontroller, which is flipping a relay on and off, if we've already taken that as our base criteria, you could try something like this, and if it doesn't work, you could then move to the PIR without having to redesign the whole. You don't have to say, I can't use a microcontroller and a relay anymore. You can just go, this sensor doesn't work. Let me try something else.
I think that's an excellent point. I think that's another reason why the microcontroller-centric approach to so many of these projects is so appealing, because of that flexibility. Or you could even say, well, I want 2 or 3 sensors, and if all 3 sensors line up with the right information, then I have high degree of confidence that I'm in this state or that state.
Well, and the nice thing is that is an iterative approach, which I'm very much in favor of. Okay, so
is that an agile thing?
Yes. Yeah. Well, yeah. So, in general, we're going to try to do a single box that will power both a little 5-volt power supply powering the micro. We're going to use a micro, and honestly, we're going to recommend something that's Arduino compatible, because as George, I think you pointed out in the last episode, there are libraries for everything. So any device you're going to pull off the shelf, you're going to run into, a library for it, or the code already written for it, and people who have used these things. Networking is optional to keep Nick happy. He will have the app live in the App Store by the time this episode airs. We are talking about having 2 sets of wiring running up to the workbench. One is a switch, which you could probably just do like some 3M foam tape or something onto the side of the soldering iron body. And then another line running up to the back of the soldering iron cradle.
Sounds good. Okay.
So really at that point, the only thing left to talk about is software. So, I mean, you guys kind of corrected me earlier about if the thing stays hot, the software we're going to write, there are going to be ranges of measurement, et cetera. So what are some of the high-level approaches you guys would consider in writing the software for this micro?
Well, I mean, it's a fairly basic problem. It depends on how fancy you want to get. So there's just some very simple components you would need in terms of software. You need the ability to read the sensor state, and then you need some timer logic. So the basic software in any of these microcontrollers, and let's take an Arduino as the example, but they're all fundamentally the same. you basically power on the microcontroller. It goes through some initialization stages to set up the pin directions and reset variables and such. And then it goes into a infinite loop. And in that loop, it does whatever the function is that the thing's supposed to do. So in that loop, it's going to start out by measuring the sensor values. And then there'll be some logic that says, based on what I've measured, then take some action. And the action in this case is either energize or de-energize the power relay to the soldering iron. So in its most basic form, the software is actually pretty simple. You could probably write the whole thing in a dozen lines of code to get a very basic functional product working.
Okay, that makes a lot of sense.
Like you said, Jeremy, there's a library for that chip. So you just say at the beginning of your file, I'm using that chip. And then there's probably an initialization line of code that says, go find this chip on the wire. And it comes back and says, okay, I'm here. And then you say, give me your temperature. And based on that temperature, then you just make the decision to flip the relay on or off. And then the software just loops around and around forever at a super high rate of speed. That's pretty much it. If it detects that it has been in the same state for a long period of time, then eventually it'll flip the relay off. And so there's different ways of doing that long-term timer thing. So you could do some very elementary loop counting with delays. That sort of thing is very crude, but very easy to program. If you want to get fancy for long time, let's say like a half hour, which in microcomputer clock cycles is a lot of clock cycles, you could add another chip to this, which would be like a clock chip, and you would read the time in the clock chip. And if the state of the sensor is always in the I should be off condition for that 30-minute period or whatever you program, then you can have it shut it off, and you're actually reading a clock calendar chip. And those clock calendar chips are like $3, and they're pretty easy to work with. That would also give you another feature too, which is you might say, well, I'm never going to use my soldering iron between the hours of 1 in the morning and 6 in the morning. And if it's ever on at that time of day, then don't turn on. Maybe a lot of us are working on the bench at 3 in the morning, so maybe that's a stupid feature. But
or to have it turn itself off after at midnight every day, just so you.
Yes.
If it was internet connected, we'd have NTP and time.
Touche.
Wouldn't
I
need
got to
that
tell
clock.
you my clock chip story. So my clock chip story is I have these Dallas Semiconductor, who is now Maxim, anyway, DS 1307 or 1302 clock chips, and I was going to use one for a little throwaway project, and it turns out that they're not super accurate. They kind of drift. Also depends on the crystal you use. Anyway, there's a replacement for it, which is a Dallas Semiconductor part, a DS3231, which has a built-in temperature compensated oscillator, a TCXO. So that's a better chip to use. And if you go to DigiKey, I looked it up, and I forget how much the chip was, but it was like $4 or $5 for the chip. And I thought, well, that's all right, I guess, for this project, because it's a clock calendar chip. It'll keep track of the day, date, year, hours, minutes, seconds. So that was great. And then I went on eBay and I looked to see if I could find one there cheaper. And up came a circuit board that has that chip, some external support components, and an EEPROM, a little E-squared PROM on the circuit board with a battery holder for $2.47 shipped post-free.
That sounds just
China.
like the $10 DDS on the $4 board.
Yeah, exactly. So I'm looking at this like, wait a minute, this makes no sense in reality. That the raw chip is twice the price of a circuit board with that chip and another one on it. So I went. In fact, I couldn't resist. I bought 10 of these stupid little circuit boards. I'll bring a couple to Pacificon and hand them out if you guys want them. It's really cool. It's a great little device. And back to the Arduino code availability, you just search for DS3231 and there's all kinds of examples of code. So yeah, you could for $2.50 make this thing even fancier
with the LCD display as well.
You could do that
with the countdown.
Yeah, there you go.
And then you can add an audio driver and play the final countdown when you only have like 5 minutes left before it's going to shut itself off.
I think I want to put a toggle switch on it and a little motor. and have the little hand come out of the hole on the top and
the
have
useless
it flip
device
switch off. Yeah, exactly.
Well, that's what it would have been if we were powering it off the mains that it was going to cut.
That's right.
I mean, there are several lessons to be learned here. Well, as we start to kind of wrap it up, I'll go around. Beric, what are some takeaways you'd like to leave folks with based on this project and this spirited conversation?
One, when you're messing around with mains voltage, safety is more important. So I think that's a big givey, and we've maybe been a bit flippant about that, but it's important. It's important, folks, be safe. My other takeaway is you can make it as complicated as you want to and learn as you go along about how to do things. So I would probably start simple and add features to it if you want.
All right. And Nick, your thoughts?
It'd be a lot faster if I just, did it myself and didn't ask for input.
Well, isn't that what you've been doing?
I don't know. I really enjoy the discussion, particularly because it really it opens your eyes as to what other people think about or the process they go through whenever they're designing something. I've never worked professionally in an environment that was hardware, software design. So I've never been privy to meetings like this. Beric, is this what they're like?
Not generally. We tend to err on the side of, if there's a simple solution, we've already done it and saved the meeting. This is simple enough where any credible engineer, dare I say it, would have just come up with a simple solution because it is a simple problem. But as an exercise in, if you scaled this up to something bigger, then yes, there is a certain amount of brainstorming. And yes, I'd say this is somewhat representative. You have a bunch of ideas you put on the board, and there might be a simple solution, which someone mentions further down, like what if.
When do we break out the Kanban board?
Have you got a Jira account going yet?
Any final thoughts from you?
I guess my main observation, or for listeners, is that for so many projects that we can imagine, in the past, there's a lot of hardwired, hardware-based behavioral stuff you would build with fixed purpose chips and timers and whatnot. And I think now so many of these projects could be done in software, but you need to have some familiarity with these microcontrollers. And I think it makes solving the problem a lot easier. And if you've never had the experience of programming with these things, I think it's really worth your time, because by experimenting just on this one project, if you built this thing as we described it, and you figured out how to write a little bit of software to make it work right, then that's a very powerful building block to work on the next project, because those little simple software development skills will carry forward into the next project and the next. And what you'll find is that these microcontrollers and their peripheral chips make the design and implementation of fairly sophisticated systems very easy, or at least relatively easy. And it's just a really useful skill set to have. So I think my big takeaway is take a simple project and use it as the basis to learn about how these microcontrollers work, like an antenna analyzer, for example. There's another good basic project.
That brings up a good point, in that the thing that I was talking about a moment ago, the box that has the prongs built into it, and design a board, and the components that are going to be on that board, such as the assembly, very small pitch. There's pads on the bottom. It's not something that you're going to hand solder. So that means you got to make a board. You got to get it fabricated, assembled, all that stuff. And then you got to write the software. There's a strong case to be made for, the Adafruit SparkFun route. Keep in mind Beric's caution about working with live wires, but a lot of these components that we're talking about building here are already available off the shelf without having to design the board. You just connect a few things together, and then it's all software. So if you don't want to get into starting with board design, if you have no experience with board design, then take a look at these off-the-shelf modules that can get the job done. And then it's just a matter of working with the software.
Yeah, I think that's a really good point because, as the one in this group who certainly has the least amount of experience in this, I'm, sitting at this table with you guys, I feel like I'm, to steal a phrase, standing on the shoulders of giants. Like for me, the modularization of all these one-off boards that are available is what makes this, accessible to me as a hobby. Nick, when you started, I think you remember. I remember you talking about. I just started looking at what chips were out there, and then started looking at reference designs, and then was like, "Well, crap! I'm going to have to learn how to start drawing these boards." And you had to go through a little bit higher of a learning curve than the average person was. But everything we've talked about today, you can get everything you need just about, except maybe that cool enclosure you mentioned from Adafruit. And what you're going to pay as a premium to them to buy these pre-built boards is going to get you a quicker time to solution, therefore probably lead to less frustration.
A lot of these modules are what they call breakout boards. They're a little tiny circuit board, like an inch square with maybe one chip on it, and it's a surface mount chip. So those are hard to solder by hand. But the breakout boards all take those surface mount chips and route the pins through traces to through-hole headers, through-hole pins. And those are easy to solder to, those holes. So your project may wind up being 2 or 3 or 4 little breakout boards, and the only thing you have to solder together are just jumper wires between all the boards, which is really easy to do. So no surface mount required and no custom circuit boards to be made to make some pretty sophisticated projects. So I think that when you were talking, Nick and Jeremy, that's really what popped in my mind is this huge number of these breakout boards, like this timer board I mentioned. That thing has header pins coming off the end of it, and you could easily solder to the solder pads on that board. So no custom boards required, and no fancy surface mount soldering. I would suggest not only Adafruit or SparkFun, another good source, but just go on eBay and search for Arduino breakout board, and you'll find hundreds of boards with sensors and relays and switches and LEDs and you name it. And you can get a whole pile of these little boards, and they're pretty cheap. They're like, $2-3 maybe or less, and cobble your project together out of those boards.
It's not a problem for Beric with his Metcal over there.
No, there's no cobbling over there. It's like using a Ferrari to solder. All right, well, gentlemen, I want to thank you all very much for taking the time to walk through this. One more takeaway I do want to bring out is, one of the things is that it kind of took a little bit of conversation to even kind of circle around on agreeing what the problem was. And that's oftentimes in situations like this, a lot of the initial conflict is agreeing what the problem is you're trying to solve. And when George was asking me things like, do you want this gadget to be inside the soldering iron or the outside? It's one of those things where it's like, well, I want the best solution. So I don't have an answer for that. And in my mind, truthfully, coming into this, I was fully expecting a solution where we were going to tap into the physical electrical switch, have the microcontroller and relay combination that I preferred, and that you would be trying to tap off voltage inside of that thing and doing a lot of stuff with that. But now that we've gone through this exercise, I really think it's elegant if we can find the enclosure that Nick was referring to, whether it be a wall wart or a, something that has cabling come out of both sides. Like that, to me, is a much more elegant solution for the cost of 2 wires coming up to the desk. And it's certainly a lot safer. I don't run the risk of destroying my soldering iron any more than I already have. So, this being open-minded throughout the process is also really critical to getting in a solution. So thank you all for your help. I'm going to try to start sourcing parts based on this, and if I can get some traction on this in some time, we'll try to do a video series on solving this very problem.
And now you got me wanting to take the temperature probe and stick it by the soldering iron and figure out what we see.
Well, since you probably have like a drawer full of them, why don't you do that?
I'll take that as my homework assignment.
That would actually be really awesome, and then we'll post the results somewhere.
Yeah. And by the way, I just want to echo one of the thoughts you had there. Is I love the idea when you have this kind of discussion, you go into it with a preconceived notion of how you do it, and a lot of times you think, oh, well, I do it this way, obviously, and then by the time you get to the end of the process, you get everybody else's input, and you think, Oh, wow. Actually, that other idea was kind of better. So you never know. You might actually learn something.
I'd still go for the 555 with the relay.
Why stop there? Why not a pair of 6LQ6s and some capacitors?
Yeah, see, and this is one of the things you guys are all talking about, analog discretes, and I'm useless without a microcontroller that I can write some software for. So
I think George just dated himself there.
Yeah, those were tubes, I'm assuming.
Yeah, that's right.
Yeah, I just realized when you said 6L6. Sorry. Well, folks, thank you very much for listening. And gentlemen, I wish you all well and have a great time at Pacificon. There you have it, folks. As you can see, the idea which I had in the beginning, which was to try to embed something inside the case of the soldering iron and try to tie it to the mains voltage coming in and being wired directly into the switch, is nothing at all like what we came up with, which is having a nice discrete unit that is closer towards the power or the plug of the wall. And of course, working with these guys, we came up with the idea of creating this to be more extensible than just solving my specific problem for my specific soldering iron. You know, hopefully actually getting to see people walk through the design process was something that was helpful to kind of help shape your mind as to how to think about this. Now, we'll be back next week with a regular episode of the Ham Radio 360 podcast. And the week after that, we'll be back with a new and exciting episode of The Workbench. In the meantime, if you have questions, feedback, or anything you'd like to share with us here at The Workbench, you can reach me at jeremy@hamradio360.com, or you can reach George at hamradio360.com. I'm primarily accessible in the social sphere by using Twitter, and I'm at KF7IJZ. George is at KJ6VU. Don't forget, if you are new to the show, take a moment and go back and listen to all the wonderful content in the back catalog for both the Workbench and the Ham Radio 360 flagship show. Thank you very much for listening. Don't forget to check out our friends at mcmelectronics.com and save 5% with the code RADIO5. We'll catch you next time. 73. Did I lose everybody?
No, I'm here.
I think we're all solving the problem before defining the requirements.
That's why I kept it very simple and open-ended.
I'm a hardware guy, and when they tried to bring hardware for Agile for hardware into an employer that I used to work for, there was all sorts of issues where we were just trying to solve the problem before defining it. And that's exactly what we're going through now, I guess.
Yeah, what he said.